Hi students, today we are going to learn about the chapter 6 squares and square roots. So we know that the area of square is equal to side into side. The side means the length of the side in the square, right? So study this following table. So if the side of the square is 1, then the area of the square is 1 into 1, which is a 1. This we can represent as a 1 square. The 1 raised to the power 2, we call it as a 1 square. If the side is 2, then the area is 2 into 2, which is equal to 4. That's a 2 square. We can represent as a 2 power 2. 2 raised to the power 2. Because multiple, you can see the both for the same number. 3 is 3 into 3, which is 9, which is equal to 3 square. 4 into 4, which is equal to 16. These are we can represent as a 4 square. 10 into 10 is equal to 100, which we can represent as a 10 square. So whatever the number, let me consider the variable a. So the area of the square will be the a into a, which is a square. So here we go for the properties of square numbers. So let's just observe the table here. The number and the square is given. So 1 is given, 1 is the number, and the square of the number 1 is 1. So square of the 1 is 1. And here 2, the square of 2 is 4. 3, the square of 3 is 9. 4, the square of 4 is 16. 5, the square of 5 is 25. 6, the square of 6 is 36. 7, the square of 7 is 49. Number 8, square of 8 is 64. 9, and the square of 9 is 81. 10, and the square of 10 is 100. Clear? So with this pattern we can observe more things. Let me show you that. You can see it is end with 1. The square number is end with 1. Then the number should be like 1 and 9. If the square number is end with 4, the number is like 8 and 2. The square number is end with 9, the number are the 7 and 3. And the 6, it end with the 4 and 6, and the 5 will end with the 5, and the 10 will end with the 10. Clear, right? So these things we can observe, right? So all these number end with, generally you can check all these numbers ending with 0, 1, 4, 5, 6 and 9, right? 0, 4, 9, 6, 5, 9. No other numbers it's in, right? So all the square numbers will be end with 0, 1, 4, 5, 6 or 9. None of these end with 2, 3, 7 or 8 at unit place. If any numbers end with 2, 3, 7 or 8, sure we can say it is not a square number. Clear? If any number is end with a 2, 3, 7 or 8, it is not a square number. Clear? Next. Number has 1 or 9 in the unit place, then the square end in 1, right? The number has 1 or 9 in the unit place, then the square ends in 1. You can see, that's what you can see. The number is end with the unit place is a 1 or 9, the square end with 1, right? The same, the number has 4 or 6, the unit place, then its square end with 6. You can see the 4 and 6. 4 and 6. The unit place end with the 6. Right? The same for the number if it is end with an 8 and 2, 4. Right? 7 and 3, that is 9. And if it is a 5, it is a 5 and 0 and 0. That's what we are going to see next. The number has 5 in its unit place, then its square end in 5. If the number has 0 in the unit place, then the square of the number end in the 0. Right? So these are the patterns we can observe from the square tables. So here we go for the next pattern. The numbers between square numbers. How many numbers between the square numbers? So 1 is a 1 square. Next to the 2 and 3 is that, which is not a square number. And 4 is a square number, which we will say the 2 square. Then 1, 2, 3, 4. Next you can see 5, 6, 7, 8. 9 only we have a square number, 3 square. But 5, 6, 7, 8 doesn't have any square number. and 10, 11, 12, 13, 14, 15 and 16 it has a 4 square. So 1, 4, 9, 16 are having a square numbers. In between you can check the 1 and 2, 3. There, so 2 digits are there. Here 1, 2, 3, 4, 4 digits are there. Here 1, 2, 3, 4, 5, 6 digits are there. Here also you can see the beautiful things. The previously there is a 1, so 1 into 2 is 2. The previously there is a 2, so 2 into 2 is 4. Previously there is a 3, 3 into 6 is 3 into 2 is 6. It's like now 1 into 2, 2 digits are there. You get 2, 2 into 2, 4 digits are there. 3 into 2, 6 digits are there. So it also contains a pattern with the digits. We can find how many non-square numbers are there, right? So consider here as a 3 square and 4 square as an n square and n plus 1 square. It's a consecutive number, right? Or if you want to know how many non-perfect square number is there between the 3 and 4, that you consider this as a n and n plus 1, right? N and n plus 1. This the square is a square and n plus 1 square. Then there are 2n non-perfect square number. So n is always leads the smallest number. So 1 is a, that's what we see here, right? There are 2n non-perfect square number. Example, 6 square and 7 square. How many non-perfect square number in between this means 2 into 6. We can say this is considered as a n, the smallest number. There are 12 non-perfect square numbers between the 6 square and the 7 square. Clear? And next, adding a odd numbers. So here also we will get a square number pattern. See, 1 is a 1, again it's 1 square, 1 plus 3, we are adding the continuous odd number, it's a 4. 2 square, 1 plus 3 plus 5 is a 9 is equal to 3 square, 1 plus 3 plus 5 plus 7, consecutive odd numbers, right? 16 is equal to 4 square, 1 plus 3 plus 5 plus 7 plus 9 is equal to 25, which is also a odd square numbers, 5 square, right? So here you can, the beautiful pattern you can check. Here only one number we choose, so 1 square. Here there is a 2 number, it's 2 square. 3 odd numbers we added, 3 square. 4 odd numbers we are added, 4 square. 5 odd numbers we added, it's a 5 square. So if you add any n odd numbers, you will getting a n square, right? If you are adding a 10 odd numbers, then we will be getting a 10 square, which is 100, right? So generally we will say sum of the first n odd numbers is a n square. This n can be takes any number. For 10 odd numbers, 10 square. 100 odd numbers, 100 square. Right? Beautiful pattern, no? And here the next, a sum of consecutive natural numbers. So here it's dealt with the consecutive natural numbers. You can see. So 3 square is equal to 9, which we can represent as a 4 plus 5. It's a consecutive natural number, right? And 5 square is a 25, which we can write as a 12 plus 13. And 7 square is a 49, which we can write as 24 plus 25. 9 square is 81, you can see 40 plus 41. 11 square is a 121, which is 60 plus 61. 15 square is equal to 225, which is 112 plus 113. So wow, we can express the square of any odd numbers. You can see that we have chosen only the odd numbers. So we can express square of any odd number as sum of two consecutive positive integers. So positive numbers we can write. So any odd numbers if is squared, and that answer we can express in the sum of two consecutive numbers, right? Only positive numbers we are taking. So here we go for the next pattern, product of two consecutive even or odd natural numbers. So I have chosen here odd numbers. So 11 into 13 we can represent as a 12 minus 1 into 12 plus 1, right? So 12 minus 1 is 11 and 13 is a 12 plus 1, which is in the form of 12 square minus 1. These are identities, a square minus b square identities. So 13 into 15 we can represent the 14 minus 1 into 14 plus 1 is equal to 14 square minus 1. 29 into 31, 29 we can represent as a 30 minus 1, and 30 we can represent as 30 plus 1, which is equal to 30 square minus 1. And here a plus 1 into, so generally we are considering any number, a plus 1 into a minus 1, that you can say a square minus 1 square. Even this suit for the even numbers. Let me show you the even number. 12 square into next even number is a 14 square. Just make sure it is a consecutive, right? So 12 square into 14 square, this we can write as a 13 minus 1 is a 12, right? Into 14 we can represent as a 13 plus 1 square, right? So this we can say as a 13 square minus 1. So for any a plus 1 and a minus 1 format, we can represent as a square minus 1. So here we go for the problem. What will be the unit digit of the squares of the following numbers? So they are asking of only the unit digits of the square. Unit digits of the square. Then we can, it's just enough to concentrate on the unit digits of the number. Find the square of the unit digit of the number. That will be the unit digit of the square also. So here in unit digit 1 is there, right? Then square of 1, that is 1 square is equal to 1, right? Then the unit digit of square is also the 1. So unit digit of this, therefore unit digit of the square of given number, square of 81, given as 81 is 1, right? So first choose what is the unit digit in the number. 2 is the unit digit of number, right? First you have to choose from the number, right? Then square it. So directly I will write 2 square is equal to 4. Then the unit digit of square of the 272 is also the 4. Therefore the unit digit of the square of 272 is 4. Clear? So first you choose what is the unit digit in the given number. The given number, the unit digit is 1. So 9. 9 is the unit digit. So the 9 is, you can represent the 9 square is an 81. So here the unit digit is 1. So this will be the unit digit for the square of the 799. So therefore the unit digit of the square of 799 is what we obtained here, 1. So this is the 1. Here we go for the next problem. The following numbers are obviously not perfect square. Give reason. So this is not perfect square, right? The given is a not a perfect square, but they are asking the reason. Why? Do you remember that? Wait, I'll show you. The square number will not end with 2, 3, 7 or 8. If it is end with 2, 3, 7 or 8 at the unit place, then it is not a perfect square. So perfect square always end with 0, 1, 4, 5, 6 or 9, right? So it is given that is not a perfect square. They are asking the reason. The reason is non-perfect square number will end with 2, 3, 7 or 8, right? Therefore 1005, it's at unit place. That's very important, at unit place. So in the unit place is 7 is there. So therefore 1057 is a perfect square. The same here, right? 23,453 is not a perfect square, obvious. The reason is its unit place is 3, right? The unit place of the number is 3. So non-perfect square number will end with 2, 3, 7 or 8 at unit place. So here the unit place is 3, so which is a non-perfect square. Therefore 23,453 is not a perfect square. Clear? We'll go for the next problem. Without adding, find the sum. 1 plus 3 plus 5 plus 7 plus 9. You can see it is a consecutive and odd numbers from the beginning, right? So we can easily say how many numbers are there with that. I'll remember you, right? We already saw this pattern, right? If the one odd number is a 1 square, 2 odd number is added 2 square, 3 odd number is added 3 square, 4 odd number is added 4 square, 5 odd number is added is a 5 square. Here the same we can use here without doing the sum. So totally how many numbers it's added here? 1 2 3 4 5. So it is a 5 square, which is 25. So without adding we found, right? The same here, 1 2 3 4 5 6 7 8 9 10. So that is a 10 odd number, that's a 10 square is the value. 10 square is nothing, 10 into 10 100. So without adding we found a addition. So next question, express 49 as sum of 7 odd numbers. The same 7 odd numbers. The first 7 odd numbers we added, sure it is a 7 square and it will be the first 49, right? So 1 plus 3 plus 5, 7 plus 9 plus 11, totally 7 is there. 1 2 3 4 5 6, one more 13. If you add 13 numbers are there, 13 odd numbers begins from 1 1 2 3 4 5 1 2 3 4 5 6 7. So it is a 7 square, which is equal to 49. So 49 can be expressed as the sum of odd numbers 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. Clear? So here we go for the next problem. How many numbers lies between squares of the following numbers? 12 and 13. It also have a pattern. We have seen the n 2n non square numbers will be there, right? So just remember that, just we see that consecutive square numbers 2 square and 3 square means 2 2s are 4 non square numbers will be there, right? So the same, we will consider it as a 2n non-perfect square numbers are there. So how many square numbers lies between the square of the following? So here is the 12 and 13. The 12 will be the n. So 2n, here n is the 12. So 2 into 12, which is a 24. Therefore 24 numbers lie between squares of 12 and 13. Clear? The same, the next is 25 and 26. The smaller number is 25. So 2 into 25 is equal to 50. Therefore 50 numbers lie between squares of 25 and 26. Squares of 25 just written in the word. Previously it is written just like 25 square and 26 square. The same thing I written in the word square of 25 and 26. With this we can represent as a 25 square and 26 square also. Thank you.